The guys at Double Fine are amazing. They make really good games, and they made this article here that is on my backlog for quite some time, and now I want to read it because it looks really, really cool. So, behind the code designing Raz Jump, Raz is the protagonist on Psychonaut, the player. Devin Kelly-Sneed has been at Double Fine since 2016, and he's one hell of a programmer. Some of you might remember his Amnesia Fortnite project from 2017, Darwin's Dinner. For Psychonauts 2, Devin acted as the player movement and powers feature lead, helping to make sure that Raz lapped with acrobatic grace and blasted bad thoughts with flashy flair. He's kindly written outlines on the implementation of a few features. Today we are gonna have him guide us through the design of Raz Jump. I'm quite excited. I really want to read this, and that's what I'm going to do now. All right. Let me have some water first. So, jumping is one of the most important player actions in Psychonaut 2. It's kind of like a platformer game, like a 3D platformer kind of game. You need it to reach higher grounds and cross perilous gaps. You use it to grab floating collectibles and avoid enemy attacks. And often you use it just to have more fun as you run around. Boing, boing, boing. Interesting, because I do this all the time. If there is jumping in a game, I usually play the game by pressing the jump button a lot. Just like multiple times. While I'm just like walking in a normal path. So, you know, it's good that they are self-conscious, there are players like me. While jump may seem like a fairly simple concept, there was actually a huge amount of work by a cross-discipline group of people to get to the version of jump that shipped. This article will talk about some of the design and implementation details for Raz Jump in Psychonauts 2, and hopefully give you a sense of the types of work involved in developing a major gameplay feature. That's really good. And that's the kind of, like, when you're really deep into specialization in a, you know, as a gaming company starts to get big, you start to get really deep into some like very specializations and very specialized people for specific mechanics, right? So it's just like if you take a look at, for example, the job openings for a company such as Remedy, you know, they have like people specific for camera, people that are very specific for player movement, player that, so that's always like this kind of specializations that go when you go like really deep into some mechanics as like the game becomes more complex, right? So the jump arc, we wanted the jump to feel responsive, reach a specific height and distance, and allow enough air control for the player to land precisely where they intended to. We achieved this with a quick launch, having the peak of the jump be a bit floaty, allowing steering while in the air, then dropping sharply towards the ground. We don't need to get into a lot of math detail, but it's worth briefly thinking about the equation for a max height for an object launched upward at velocity v. The important thing to understand is that increasing the launch velocity increases the jump height, sure, and increasing the gravity will decrease the jump height, sure. So this is like the parabola kind of equation here. Quite simple. We want Raz Jump to reach a specific height that corresponds to the obstacles we place in those levels. By tuning the gravity and launch velocity, we can achieve the same height with drastically different jump arcs. Low and floaty, or a very quick launch and fall. So let's take a look. Low velocity, low gravity. Okay. It's good to have like this kind of like path tracing here, so we can see what's going on. High velocity, high gravity. Okay. So it is the same height, but the distances differ a lot, like the maximum distance you can travel from the ground. But neither of those feels very good. Yeah, the slow one feels very floaty and sluggish. The quick one can't cover much distance, yeah, and gives too little time to make any steering adjustments. You can choose one somewhere in the middle, but that still doesn't achieve the feel and distance height that we wanted. To define our jump arc, we design a system that breaks the motion phases, which can each be tuned independently. Each phase has settings for things like launch velocity, gravity, and duration. This allowed us to have the jump rise quickly, responsive, float for a bit, cover ground and aim for your landing, and then drop down, land where you intend to. We also allow the player to control the size of the jump based on how long they hold the jump button. Interesting. So I think those are the three phases, right? I don't know why it's pink here in the middle, but it looks like we got the early phase here of the jump, which is basically launching the player, and they have like a set parameters for gravity and stuff. Then you have like the steering part, the steering duration here. I don't know what, I know again, like why this is pink, but this looks like the steering part. And then this is the fall, the gray part here. Huh. That's nice. To achieve the quick launch, we start with a high launch velocity. We keep this phase from getting RAS too high by pairing it with a high gravity. This phase is tuned to end once RAS vertical speed is approaching 0. Okay, so here it is approaching 0. Then it changes to the next phase. The next two phases are tuned with a low gravity, so that RAS will stay at about the same height for quite a while. Those are each tuned to end after a specific duration. So, interesting. So the first one is tuned to the vertical speed movement, or the vertical speed like value, nominal value. And this one is tuned for a duration. So for example, this will happen in like 2 seconds, or like 2 seconds. 2 seconds is too much, but yeah, like probably a certain amount of seconds here. And finally, we briefly increase gravity to achieve the quick drop before ending the jump and returning to default gravity. We allow the first two phases to end early, with a minimum duration, if the jump button is released, resulting in smaller jumps. Okay. Jumping, holding button left and releasing button right. So if you hold the button, it will go for a while, and then apex, 225 units, full apex, 227 units. Okay, so this is the full apex, the maximum amount that he can jump. And this is if you do this quite quickly, which is 147. It's interesting because there's a very sharp difference between, like, if you go this full jump here, there's a full arc. And if you jump just a little bit, then you float. It kind of like feels like you float for a little bit. I haven't played Psychonauts 2, only played the first one. I think I can compare the movement a little bit because I remember how the jump works, how jumping works in Psychonauts 1, right? So I can more or less like feel how this movement would work here. But there's a very sharp distinction between like this first part, the first motion and the second motion here. For reference, here are the approximate values we shipped with. Velocities are in centimeters per second. Okay, so units here are 2 meters. If this is centimeters, this is like 2 meters and 27 centimeters. Velocities are in centimeters per second. Gravity percentage is a multiplier of the default gravity. RAS is around 125 centimeters tall. Gravity multiplier. So they have like a default gravity number, which makes sense. Like you always, that's what something that I wanted to understand was that if they changed gravity, but they just have a gravity multiplier and the same default gravity number for everything, which makes a lot of sense. You're doing like, if you're dealing with lots of objects, it's better if you have a set number, a set physics number for everyone. It's a constant number. Then you just like add a multiplier for the jumping. So launch, there is no end time for the launch because it changes phase according to its vertical velocity, but there is an end time for float A, float B, and then fall. Okay, so there are two colors here because there's float A and float B, I guess. Why though? Duration if button is released. Oh, so float A is for it's when you keep pressing the button. Interesting. That is something that I didn't quite understood here. Like I understood, if I understood correctly, the launch distance here depends on if you're releasing the button early or not. But apparently, the second phase also depends on whether you release the button or not. So what I'm thinking here is that when you press the button, you stay in the air for a while, and when you release the button, or like once you have like a maximum amount of time here, then it will end to the next phase here, the jump, right? But if you release the button super early, then everything is the minimum amount of time. I think so. I think that's how it works. Animation. The animation that's also a really good topic here. The animation for res ground jump is divided into 3 animation sequences, which are associated with the phases of the jump: launch, float, fall. For our four-phased ground jump, the middle two phases were both tagged as float for animation purposes. So launch. Okay. Okay, it's on loop, I guess. Float. You can see how they stretch a little bit his whole model. Fall. Okay. We had several variations, so the jump doesn't look like the same every single time. Ah, interesting. Several jumping animations. That's good. Okay. VFX and audio. We triggered most audio and particle effects through animation notifies. Here's an example of the animation for starting a ground jump. We triggered most audio and particle effects through animation notifies. Okay, so the animation, during the animation, there will be like a notification for the audio particle system to play something. Here's an example of the animation for starting a ground jump. Okay, notifies. Where does it notify? Like, does it notify at the beginning or at the end? If it is at the beginning, then everyone is notifying at the same time. So it doesn't make sense, right? Interesting. The A key event notify is for triggering a sound effect. Okay, so the first one. Play dialogue set triggers res jump voice like huh. The footstep hand plant notify sends an event to a system that can trigger audio and VFX based on the event and surface type. Ah. Footstep hand plant notifies an event to a system, so there's a specific system for different sounds based on surface. Nice. Here are the settings for a jump event at the bottom of the character's capture collision. Animation notify body part, capsule bottom, intensity, jump. Here you can see the different launch VFX for two different ground surfaces type, dirt and honey. Okay. I think I have put sound on OBS here. Yes, continue. Huh. Okay. Good. This is honey. Ah, look at the VFX. Cool. Metrics. Early on in the project, we spent some time deciding on the jump metrics. This is a set of measurements that can be used for level design. How high is a jump? How far can you get if you double jump? By codifying those values, we enable level designers to build content that will fit the desired platforming experience. For example, they can make a jump covered by a single jump on an easy path, and a gap that requires a double jump on a more challenging path. Nice. So they set up first what was the maximum distances I understood correctly. And then they codify this on probably on their jump mechanic here, on this path here. So they know that the maximum distance that you can cover is something that they can change in code. Is this correct? I think so. This would make sense, right? If you want the maximum distance you can cover by jumping to be less than what you have right now, you want, for example, 200 centimeters, which is the unit they use in the game. Then you want to set up so that, but how would they set up here? Like, do they have like this one value they change and every trajectory here, every phase of the trajectory adapts to this number? And the resulting equation is the total amount of value? That's one thing that I wanted to understand. Metrics. Early in the project, we spent some time designing on the jump metrics, the set of measurements that can how high is the jump, by codifying those values. They codify those values. They codify the maximum. They codify how far they can reach. So I'm expecting that each phase of the jump then use this maximum amount of value. And once they change it, every phase of the jump just adapts itself. I think that makes sense. But yeah, as production went on, we sometimes run across situations that resulted in us wanting to adjust or add metrics. Adding moves that allowed Raz to jump higher or further meant that previous understanding of what is possible could be invalidated. This type of change has to be made very carefully to avoid requiring too many layout changes in levels. Visualization features. We had several tools available for visualizing jumps. Each served a different purpose. That's really cool. That's the kind of tooling that I wanted to know more about, like in platforming games. So they had a lot of tooling in their own engine to make things easier for level designers and game designers. Active jump debug crawl. This allowed us to see what happened on a particular jump. The shape of the arc faces the apex height and the distance covered. This is useful for examining how a jump behaved in a particular context during gameplay. The trail alternates between magenta and green, and at each phase change, the trail becomes gray once the jump phases are completed and we return to the default gravity. Text drawn at the apex and landing is useful for checking the height and distance of the jump. So the label there was added in engine. That's really cool. Everything that we saw there, it wasn't just like to make a beautiful article, it was for the level designers. Jump sim preview. This allowed us to preview the jump before hitting the button. This was useful when tuning various jumps to see the arc shape in the context of a level. Yeah, so they have when they said they codified the maximum amount of reach a jump can make, then basically you're adapting this for every phase of the jump so you can see the maximum arc. This was also useful for visualizing the jump arc while tuning the values. Look at the debug menu. So nice. And they have like different states trigger different maximum arcs. Oh, that's so cool. That is really useful for platforming. I mean, obvious, right? But really, really useful. Jump metrics tool. The jump metrics tool is designed to be placed into the level when the game is not running to visualize Raz jump arc. This can be used to help place objects along an action path, so they will be reachable by the intended jump type. The tool runs the jump simulation code at edit time while the game is not running. The tool runs the jump simulation code at edit time while the game is not running. Any change in the jump tuning would be reflected by the preview arc. Oh, okay. Okay, I see what it means. It's basically like, okay, so it's basically Godot tooling. Like if we were to compare in Godot, it's like you're making a tool that runs in editor time. And then, yeah, I mean, yeah, okay, now I can understand this phrasing here. The tool runs the jump simulation code at edit time while the game is not running. Okay. In this image, you can see two two jumps preview, one showing the single jump, the other showing a double jump. Nice. Very nice. Jump assets. Res doesn't just have one jump. We actually have a huge variety of jumps for different situations. I've mostly written about the default ground jump. What happens when you hit the jump button while standing or running? But Res also has the ability to jump off and on to a bunch of objects in the world. Psychonauts 2 shipped with approximately 800 jump assets, each tuned for a different use case. A handful of those were used by enemy characters for leap attack launches, but the vast majority were for Res. How can Res need so many jumps? Here's a sampling of them. Ground jump, jump off horizontal pole. Vertical pole, bounce on trampoline, jump on levitation ball. Charge jump on levitation ball, water course, bounce. Jump sideways during wall climb, jump backwards off a wall climb. Dismount big ball. Bounce off an enemy's head, leap attack, ground pound attack. Some of those ended up with similar or even identical tuning to each other, but having the flexibility to decide exactly how each jump worked without changing others was very useful. Some of those ended up very similar, they even identical tuning to each other, but having the flexibility to decide how a jump worked without changing others. Okay, so they have a set parameters for each kind of jump. That would be like very... I mean, I can understand why you would do that, but still, so many things to configure. So many numbers. Here's a look at a jump asset in the editor. This is the default ground jump. As you can see, there are a lot of settings available that allow fine-tuning the behavior. The motion is tuned in the jump phases section. The first phase is shown here. The others have all the same properties available for tuning. Full body animation overrides. There's some animation variables here. Jump phases. Here are the jump phases. Oh, so jump phases is kind of like, okay. So the jump phase is really set as kind of like, I thought it would be like more of a iterational approach maybe, but it's like a kind of a more state machine kind of approach here. You have like the first state, the second, third, fourth, and then it just goes on. Right? It really codified that way. Interesting. Can I close it? Okay. Tuning with MIDI controllers. What? No. There are a lot of variables that go into setting the desired arc shape, and you often want to tweak a couple of them at the same time, launch velocity and gravity. To make the process easier, we sometimes hook up to a MIDI controller to tuning the properties. Oh, this is amazing! To make this process easier, we sometimes hooked up a MIDI controller to the tuning properties and adjusted them by turning knobs instead of typing in values. This allows for much faster iteration when paired with the jump sim preview. It's also a lot more intuitive to see art while tuning than just inputting a bunch of numbers and then testing out. That is absolutely brilliant. Look at the fella. I can't believe they've done this. This article was worth to read just for that. Look at it. Oh my god. I would never expect that. Like, beautiful. Beautiful. And this makes a lot of sense. Sure. Like, this kind of analogical controller. Because even like, at the end of the day, you're just trying to get the values right. And this kind of like analogical controller here, we're using a MIDI controller to change the values and see them visually. This is so useful. Like, damn, this is so weird, but also so useful. Targeted jumps. Some jumps in Psychonauts 2 are designed to arrive at a specific target automatically. An example is when jumping from one pole to another. Targeted jumps were used to force a consistent arc and arrival location. A common use case for this was jumping off of something like a pole. When the player hit jump, we do a search in a predefined region to see if there are any things for us to attach to. For example, another pole or ledge. If found, we bypass all the normal jump logic, calculate a simple parabolic arc to reach the destination, and briefly disable the player air steering. Interesting. So when you jump, and you know there's something there, you calculate just a parabolic arc and go from there. But what is this? I was interested in when jumping from our pool, target jumps around, consistent RO location. Here. When the player hits jump, we do a search in a predefined region. What is a predefined region? It's just like a capsule or something like in front of the player? Or do they use... I don't think it makes sense to use the jump arc, right? Or does it? I would think that this is the jump arc, the maximum jump arc, and see if along this path here, there is a region that collides with it. And then you will do this kind of like automatic parabolic arc. But I don't know. I'm not sure like if this is using this parabolic arc or just like you could like I think simplify this by just using a collision box in front of the player, right? An collision area here. Just checking if there's something. I don't know. This allowed for more forgiving layout metrics and made certain types of platforming more consistent for players. We altered those target detectors as capsule components attached to RAS. Okay, that answered my question. Though for performance reasons, they aren't actually attached or enabled in the physics simulation at runtime. Okay. Best viewers, oh my god, Nomio, thank you so much. You are banned forever. We alter those target detectors as capsule components attached to RAS. Though for performance reasons, they aren't actually attached or enabled in the physics simulation and runtime. Updating the location or calculating overlaps on those every frame was too costly. Yeah, we cache off the relative transform and do overlap queries when needed. So they are not attached or enabled in the physics simulation and runtime. This makes sense because you only want to check for overlaps when you're jumping from here, right? It doesn't make sense to track this all the time. When picking, but I do wonder, like, when it is the best time to trigger this? Do they only trigger this exactly in the frame that you're pressing the jump? So they check for other areas to make this parabolic arc? Interesting. I would think that they would maybe just trigger when on the same frame, right? But he's mentioning caching here. Operating the location calculating overlaps on those every frame was too costly. Perfect. We cache off the relative transform and do overlap queries when needed. So they probably do both things, right? They tested the overlap only when you on the same frame that you press the button to jump when you're from a pole or something, but also they do this kind of overlapping. They cache the results. So if you do this again, you don't need to look for this area, right? Because if you're jumping from the same position, facing the same direction, you will get the same results. So it makes sense to cache those results, right? Okay, I see why you're caching. Because this is like just a static check. You're just making a static check for other platforms. No platform will change position in that time. Okay, makes sense. Makes sense. When picking the best target for a targeted jump, we consider both the distance to the target as well as the angle away from RAS forward vector. Let me read this again. When picking the best target for a targeted jump. Okay, so if there are multiple targets in the same overlapping the same area, We consider both the distance to the target as well as the angle from rest forward vector. The main case this matter was when jumping to a ledge, which is made up of multiple segments. We calculated a score for each possible segment to decide which one RAS should jump to. In this image, the blue segments were determined to be potential attach points. The red segment was discarded as being outside the green capsule targeted area. The white sphere represents the chosen target point. So the sphere is not only for like this kind of like pull platforms, also for ledge grabbing, which is used way more, right? So I can see like why this would be a performance problem. The red segment was discarded outside the target area. The white sphere represents the chosen targeted point. So he was jumping here. There was the overlap here. So the player has a normal direction here, a forward direction. And those are the distances, the ledge distances from here. So this ledge is closer to the player, but this ledge here is better aligned with the direction the player is going in. I think that's what he means, right? Interesting. Polishing the edges. Over the course of the project, we identified a huge number of rough edges that needed polish to feel reliably good. Some were things we anticipated at the start, others were discovered through testing. Here are a handful of little features that help make the jumps feel better. Perspective issues. One interesting feature is the detector we used for jumping up to a pole. We found that it was difficult to judge depth, and players might think they were directly under a pole when they are not quite to it or just past it. So for example, in this case here, he's before the pole, right? But it's hard to judge. I mean, yeah, shadows are not directly above the player. Interestingly, that's cool. Like the player got two shadows, the blob shadow and the mesh shadow. And the blob shadow is always below the player, so the player knows where he's falling into. Cool. And interesting enough, the blob shadow only appears... that's cool. The blob shadow only appears when you jump. So... blob shadow only appears... And it looks like it doesn't appear in the first phase of the jump when you're launching. It appears in the second to third phase, which is where you want it to appear, right? You want to know... It's like you want to know where you will fall, so it doesn't need to appear on the first phase of the jump. Because on this phase here, you only want to show the player mesh shadow because it looks prettier. If the blob shadow appeared here, it would kind of like lose resolution on the whole player shadow. Interesting. We're seeing some very cool looking things here. To make jumping up to a pole from below feel more reliable, we orient the pole detector based on the camera. This means that when the camera orientation makes it more difficult to line up under the pole, we are more generous with detecting and attaching. Let's see. So there is a pole detector above the player? That's what it means? Okay. Okay. Okay, so this is a pole detector above the player. And here, the player detects there is a pole in front of him, but the pole detector hasn't detected. But if he moves the camera, then it detects the pole and attaches to it. Okay, makes sense. Interesting. Jumping forward from a standstill. The horizontal motion of a ground jump is based on your running movement. However, we found that sometimes players would carefully walk to the edge of a gap and stop before pushing forward and trying to jump across. Because it takes time to accelerate up to the run speed, they will start their jump with too low of a horizontal velocity to clear the gap. Okay. So basically players would instead of running and jumping, they will go really carefully to the edge of a gap and then try to jump to the next platform. But then they wouldn't have enough speed to cross the platform. Jump from standstill without assist and with assist. Right. So this, how much does he walks here? 1 block, 2, 3, 4, 5, and a little bit. Here is 1, 2, 3, 4, 5, 6, almost. Okay, almost one full square of difference. To solve this, we bypass the normal acceleration if the player is fully pushing the movement stick when they jump, and instead immediately set the horizontal velocity to about 80% of maximum run speed. Huh, interesting. So basically you have like this set up so that if you jump from standstill, you can still reach 80% of your maximum distance you can travel. This made the creep up to the ledge approach work reliably. The difference is subtle, but made a positive impact on the game feel for one style of player. Nice. Coyote time. Famous. Like most platformers, Psychonauts 2 allow the player to jump just after they begin falling when running off an edge. This behavior is often named Coyote time, after the way the cartoon character Willie E. Coyote briefly stays up in the air after running off a cliff. This makes the control feel more forgiving. If you just started falling and hit jump, you will perform the jump associated with the previous movement mode, walking, rail slide, levitation, etc., rather than using the aerial jump, aka double jump. Interesting. Since there are a lot of jump states you can jump off, they have to store the state you were at before the Coyote time triggers. Interesting. Our implementation actually allowed for more than just jumps. When a movement mode ends, it can specify some Coyote data. This data includes the duration minimum speed to activate, and activation to do if the player hits jump, attack, or dodge. When we receive the button input, we check to see if there was recent Coyote data configured to consume that input before the current mode gets a chance to react to it. So there's more than just Coyote jump. It's basically make every kind of input more forgiving because you can add Coyote data. So if you have like a combo system and the combo system has like some Coyote data, if you lose your window to keep up the combo, but there is Coyote data, then it will basically re-trigger the combo. Cool, that's really cool. That's not useful just for platformers. We also optionally did a pre-jump, which generally just lowered the gravity very briefly. This meant that Raz will not fall as quickly when running off a ledge, and your Coyote time jump would start at roughly the same height as if you had jumped before running off. I have to read this again. We also optionally did a pre-jump, which generally just lowered the gravity very briefly. Okay. This meant that Raz will not fall as quickly when running off a ledge, and your Coyote time jump would start at roughly the same height as if you had jumped before running off. Okay, so when Coyote time starts, when this Coyote window starts, gravity is less than the normal gravity. So you wouldn't fall as far as you would. That's what you mean. For reference, Raz ground normal running movement Coyote time was 0.2 seconds long, with 0.15 seconds at 25% gravity. Okay, interesting. The pre-jump then sets the gravity to 25%, was implemented as a jump that was triggered automatically when we enter the falling movement. No pre-jump. Okay, with pre-jump. So basically, when you start falling, gravity is 25% because of the Coyote time. Cool. Really nice. Rail follow jump. When sliding on a rail, we want to jump to follow the path of the rail, so you wouldn't fall off jumping near a curve. To accomplish this, we run the jump logic, but don't let it drive Raz directly. This was an important use case for having the system operate on the jump state structure instead of on the character. It allows us to run all the jump logic without directly impacting Raz movement. We take the vertical component of the simulated jump and use it as an offset above the rail, adjusting Raz horizontal velocity to follow the rail spline curve. Interesting. I understand what this does. So they abstracted the jump state out of the character and basically use it when you're jumping on a rail so that all the logic on vertical movement stays the same. But on the XZ plane, you are still following the rail. Cool. That's really cool. I'm curious on how they did this. Like, what exactly is the jump state? Is this like, if I could compare it to something, like, is this a mono behavior inside a, I know they have their own engine, but this would be like a component inside the player character that they are abstracting in kind of like a state machine, maybe? And when you're on a rail, you're just like using this jump logic, but without directly affecting physics. Because who's going to change physics is going to be the rail. So you can force the player to be in its spline curve, right? Is this correct? I'm not sure. I feel like I'm assuming a lot of things here. But that's interesting nonetheless. The fact that they can do this using the jump state structure. System architecture. Psychonauts 2 was built using Unreal Engine 4. I thought it was like their own engine. I mean, they probably customized the hell of Unreal Engine 4, right? Most of the character motion logic is running through UCharacter movement component, a standard part of Unreal. We built our own movement mode system on top of it. But at the end of the day, the jump motion is running the built-in phys falling function with some minor modifications. We inserted a function that lets us run our jump update logic just before phys falling moves the capsule. We'll also move a bunch of small changes to support arbitrary gravity direction and associated collision capsule orientation. Nice! I didn't know they had like levels that change gravity. Our custom jump logic was mainly adjusting the gravity strength based on the jump phase and determining when to move to the next phase based on the current state. Interesting. So it's not like as complex as I thought. Like the complex part of it is determining when you're changing states, I think, because you have to store some values to do that. To support the various jump simulations, we need to be able to run the jump logic without the character actually doing the jump. Yeah. For all the tooling, right? The tooling that we saw is using this. And in the case of the editor sim, we didn't even have an instance of the character around at all. All the jump functions are written to operate on a struct called p2 jump state. Oh, that's the jump state that we saw. It contains the location, orientation, gravity, time, jump button state, and about 30 other properties to handle all sort of specific behaviors. At runtime, it also contains a reference to the actual character, allowing relevant properties like current gravity to be copied from p2 jump state to the character. But we were able to run all of the logic without impacting the character when desired. Nice. Okay, so that's what he meant by jump state. Here's an example of the functions on the jump state that allow the simulation to operate whether or not we were actually driving the character's movement. Get current velocity, alternate jump comp. Okay, so alternate jump comp. Not sure what that is. Get component velocity. If non-constant movement, then you check the member non-constant movement velocity. Oh. Return velocity editor sim. So if they don't have those references here, then you're just returning the editor simulation. Any jump logic that cared about the current velocity would use the function rather than accessing the velocity directly on the character. For example, moving down dot product, if moving down, run logic specifically relevant to downward motion. Huh. Interesting. I'm not really familiar with Unreal Engine. Like some of the, I just played a little bit, but that's an interesting kind of tooling for that. All right, wrap up. Even something as seemingly simple as jumping can end up with a huge amount of complexity when it's such a core part of the game experience. It was a lot of effort by multiple people to create the version that shipped. We hope you have enjoyed learning about a bit about design, system, and process behind ResJump. That is a really, 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 really nice article. Really like it. Like the whole scope of the thing, how deep you can get just with the jumping mechanic, and I think, like more importantly, the amount of tooling that you have to do to make this really easy, not just to tweak and to fix, but also to design levels around, because it's all about platforming Psychonauts. So this is really nice. This is really cool. And my favorite part by far is, where's the MIDI controller? I think we passed it here. My favorite part by far is this. Like, this is such a cool, ingenious idea. Really, really nice.